One of the things you can do with equilibrium constants is you can manipulate them. And by manipulate them, you can basically change the chemical equation. And by changing it, there's three main things that we're going to talk about to manipulate a chemical equation. Here's the first one right here. Here's a reaction at equilibrium. We've got the equilibrium constant. And notice that this equation right here is the same equation, but they flipped the reactants and the products. So think about that. Before, this was on the top and this was on the bottom, but now the N2O4 is on the top and the NO2 squared is going to go on the bottom. So what we've done is we've switched the position of the reactants and the products. And think about that equation, that's products over reactants. Those have been flipped. So notice that the equilibrium constant went from 6.46 to 0.155. And if you take the reciprocal of 6.46, which is 1 over 6.46, guess what you get? 0.155. So when you have a chemical equation and you flip it and you put the reactants in the products and the products as the reactants, what do you do to the equilibrium constant? You take the reciprocal, okay, is the reciprocal of the one written in the reverse direction. Okay, what if you take a chemical equation and you, let's say instead of, let's look at this one again, instead of 1 N2O4 and 2 NO2s, we change that to 2 N2O4s and 4 NO2s. What we've done is we've doubled everything in that equation. And when you double everything in an equation, you raise the equilibrium constant to that power. So let's say we tripled everything. Make that a 3, make that a 6. Well, then we have to cube everything. Let's say we cut everything in half. So this becomes a 1/2 and this just becomes a 1. Well, then you take 6.46 to the 1/2 power. So when you multiply it by something, the equilibrium constant of a reaction that has been multiplied by a number is raised to a power equal to that number. Okay? And then the third one is if you add two equations together to make a new equation. Notice what we did here is we're going to take this equation and we're going to put them together. Okay, the only thing you have to be careful of is things that are the same on opposite sides cancel each other out. See how Br2 gets made here and then it gets used here? The Br2s cancel out. So notice overall we have 2 NOBRs and Cl2 on the reactant side. And then we have the 2 NOs and the 2 BRCLs on the product side. When you add two equations together, what do you do with the equilibrium constants? You multiply them, okay? It is the product of the equilibrium constants. Now, why do you need to do this? Why do you need to flip equations? Why do you need to double them or triple them or maybe cut them in half? And why do you need to add equations together? Because sometimes we don't know the equilibrium constant of one chemical equation, so we can use some other chemical equations to figure it out. And by that I mean the following. They give us these two equations. We know the equilibrium constants for that one. And sorry, this got put in the wrong spot. This should be down here. Okay, so we know the equilibrium constants for these two equations. But what we want to know is we want to know what's the equilibrium constant for that third equation. So what we need to do is, again, we need to manipulate those top two equations to make it so when we add them together, they're going to form this equation here. So how do you do this? Well, you simply look and you look at the very first part of the overall equation. You look at what it is, how many there are, and are they reactants or products. So I need HF, I need 2 of them, and I need them to be on the reactant side. Okay, then I come back up here and I try to find HF. And again, I need HF, I need 2 of them, and I need them on the reactant side. So you'll notice I have an HF right here, but I've only got 1 of them. So what does that mean I have to do in order to get 2 HFs? I have to double that whole equation, which means I'm going to take this first equation, I'm going to rewrite it down here, and I'm going to double everything. And again, I'm kind of lazy. I'm going to leave out the aqueous parts. But notice when I double HF, I double everything in that equation. Now, what does that do to my equilibrium constant? Again, I don't really care about the answer yet, but I know what it's going to do is it's going, because I doubled everything, I have to square the equilibrium constant. Okay, let's keep going. So we've got HF taken care of. Now I need C2O42 minus, and I need one of them. And notice again, here's our arrow. It's on the reactant side. So now I come back up here again. Oh, here's C2O42 minus, and there's one of them. That's good, except it's on the product side. I need it on the reactant side because that's where it is in my equation down here. So what do I need to do to that equation? Well, if it's on the product side and I need it on the reactant side, I've got to flip that equation. So that means that second equation is going to become, I'm going to make the products the reactants, so 2H pluses plus C2O42 minus in equilibrium with H2C2O4. And when I flip that equation, what do I have to do to the equilibrium constant? I've got to take the reciprocal of it. So, and you can write down the answer. I'm just trying to show you this is what I'm doing. I'm taking the reciprocal of that number. Now, I need two F minuses. And remember, I don't really have these equations anymore. Now I have these new equations that I've written down here. And notice, here I have my two F minuses as products already. So those are good. And then I need H2C2O4 as a product. And here it is as a product. Okay? So, notice that in the first equation, I produce two H pluses, and then I have two H pluses over here. What does that mean? Notice there's no H pluses in this overall equation here. So what does that mean? It means they have to cancel out, and they do. Okay? So now to make this third equation from these 1, 2 equations here, what do I need to do? I need to add those two equations together. And when you do that, what do you do to your equilibrium constant? You multiply them. So I'm going to take 6.8 times 10 to the minus 4th squared, and I'm going to multiply that by 1 over 3.8 times 10 to the minus 6. So get your calculator out. Go along here with me. Make sure that you get the same answer that I do. So 6.8 times 10 to the minus 4th squared times 1 divided by 3.8 times 10 to the minus 6th equals, so for this equation here, the equilibrium constant, Kc or Keq, equals 0.122. Okay, and if you don't get that, check your math again. Keep doing that until you end up getting the same answer as I do. Okay, let me show you one more. Okay, so we've got, and again, I just go right to, okay, what's the equation they want me to get? They want me to get that one. So again, I need N2, I need one N2, and I need it to be on the reactant side. Well, the only spot I see N2 is on the product side, so I'm going to take that equation and I'm going to flip it. So I'm going to have N2 plus O2 in equilibrium with two NOs. And what does that do to my equilibrium constant? I've got to take the reciprocal of it. Okay, and then I need O2 as a reactant. I just made it a reactant when I moved the N2 over, so we're good on O2. I need Br2 as a reactant. Oh, hey, I already have it as a reactant right here. And then I need two NOBRs as a product. Hey, what do you know? I have two NOBRs as a product already. Okay, now notice in this second equation here, remember this isn't here anymore, now we have this equation, that we made two NOs, and notice in this equation, we have two NOs as reactants. So here we have them as a reactant, here we have them as a product. What does that mean? It means they cancel out. So what did we do to this top equation here? Nothing. We didn't flip it, we didn't double it, we didn't triple it, we didn't do anything to it. But we are still going to add it. 2 NOs plus Br2 makes 2 NOBRs. We're still going to add the two equations together. Remember, those 2 NOs canceled. So we still have to do the whole N2 plus O2 plus Br2 makes 2 NOBRs. And so that equilibrium constant up here is a 2, and we just keep it as a 2. Okay, because we didn't do anything to that equation, but of course we still have to use it. So now I'm just going to take 1, because remember, now I have to multiply those two together to get the equilibrium constant for this equation. So I've got to take 1 divided by 2.1 times 10 to the minus second. Okay, and then I've got to multiply that number by 2. And that gives me a final answer. This one is going to have an equilibrium constant of 95.2. So there's 3 different things you can do to chemical equations. Flip them, take the reciprocal, double them or triple them or cut them in half, raise the equilibrium constant to that power, and then when you add equations together, you multiply those equilibrium constants.